Hi everybody and welcome to this next video. On this one I would like to show the feature CAN Xplorer, which is included in the PLUS+1 Service Tool add-on, and the possibility to add and use diagnostic data files. CAN Xplorer is a Danfoss specific protocol that can be used to log and send generic CAN messages on the CANbus without using any hardware or PLUS+1 guide code programming. The content of the CAN messages are mapped to PLUS+1 Service Tool signals and parameters using CAN database definition files. Possible use case is to read or display the engine RPM if that is available on the CANbus. Another use case could be send some heartbeat signal using the cyclic send type. Inside Service Tool, you have the possibility to add diagnostic data files to the diagnostic application. This diagnostic file needs to be installed or assigned in Service Tool to an available protocol. Under the Service Tool menu, Communication Protocols, you will find the already installed and available protocols like the PLUS+1 protocol, where you can select a PLG file, or an UDS or Service Signal Protocol, and which is most important for this feature and in this video is the CAN Xplorer protocol. So where you can select a diagnostic data file as a DBC or an XML file. I want to show the feature CAN Xplorer, which needs to be available and selected as active protocol inside the Service Tool. After activating or installing available protocols, the diagnostic data file or files needs to be added to be active under this node for the applicable protocol once installed. Available diagnostic data file format for the CAN Xplorer protocol are DCP and the XML file. The DBC file format can be created, for example, with the free tool Quasar database editor, where you can create CAN, CANFD or J1939 databases to add and edit messages, signals, and nodes. So this is just one possibility if you feel familiar with the DBC file. Next option is the CAN Xplorer XML file. It's a Danfoss database definition. So other than DBC files and XML file format is also supported as diagnostic data files for the CAN Xplorer protocol. This file format supports some features that are not supported in the DBC file format, such as having signals from other messages as conditionals, and also having signals as offset together with a shift mask as factor. This can be used to be able to decode J1939 DM2 messages, for instance, and changing CAN ID dynamically. And this CAN Xplorer XML file format is used in the following. So select the CAN Xplorer XML file and add this to the Service Tool diagnostic. After adding this file to Service Tool, these can be opened and edited with the associated program outside Service Tool. The nodes defined in the diagnostic data file will show up as ECUs in the ECU list. The signals in the messages will appear named as message name.signal name. ECU and signals or parameters can be selected in the normal manner in the PLUS+1 Service Tool pages. I will show a bit more in detail in the following, how to use the XML file, what this file does include, how the structure looks like, and all the necessary steps so that you are able to receive and send CAN messages using the CAN Xplorer function without the need using hardware or PLUS+1 programming. Let's take a look to the XML file, which has been added as the diagnostic data file using CAN Xplorer protocol. The CAN Xplorer XML files follows the XML standardized programming requirements using CAN message format, user-specific language XML scheme. One example is available or shown in the PLUS+1 Service Tool design manual. The first part of the XML file is the XML header, which is or will be always the same and is also called XML declaration. The rest of the XML document, which looks a bit cryptic for the first time maybe, does include elements, attributes, processing, assignment, and comments, what I want to show a bit more in detail. Let's start with the header of the XML file. As I said, this is a fixed and standardized text and don't need to be changed or modified. This does include user-specific XML scheme or file format like a CAN message format. The next, or for us, the first element inside the XML file which requires our attention is network, which acts as the main ECU name listed in the ECU list in service tool together with a node. Like for a Danfoss controller with one bus and node 2, it will be displayed as 0, 2. So the 0 reflects the network and 2 does show the node. This network element acts also as the main folder of this XML file, where furthermore elements and attribute will be added to as subfolders or increased level. Like the next element called node, together with the previous mentioned network ECU specific element, which will be listed inside the ECU field. And this third and also the last element we have to take attention to is the element called message. The message represents a CAN package with up to 8 bytes, which can be assigned to be read or to be written to the CANbus. The element message does include different attributes or properties which can be used to specify the CAN package, or let's say split a CAN package in user-specific or needed signals, like the main benefit of using CAN Xplorer to decode J1939DM2 messages, for example. Let's take a short look to the message properties and its attributes, which can be used, but not all of them are mandatory. Let's start with the signal, which will be the next element where you can assign or create specific signals referring to the early created message. While signals, you have the possibility to split the CAN package called message in specific signals defining the start position and length of bits. Starting with the element decode to specify the signal using the start position, length, endian, and sign. So in this little example, the signal array D0 does include data from bit 0, the start attribute, from the received CAN packet message with a full size of 8 bits, which is 1 byte, so the length attribute. Another attribute for signals is scale, to use the factor to multiply value and offset to add value. Also another attribute is range, to set the read signals to this range, min and max. As long the signal is not in defined range, a warning or an error will be reported. Besides the attribute to predefine info like a value unit, you can also set up conditions for specific cases using signal name and the signal range min and max. As you can see in this little example, an AND condition has been assigned to a signal. So as long as the condition cases are not met, the signal value appear. For conditions, the logic AND, OR, and NOT are available. Here you can also see how it looks like in service tool. If the condition is not met, the signal appear, and it is shown with red frame. This example shows the condition. As long the condition for that signal is not met, the signal appear with red frame, as I said. If the condition is met, the signal will be shown and the red frame is gone. This example uses an add condition of the value range of 2 signals. As long the range condition of both signals is not met, the signal will not be valid and shown. Besides receiving CAN messages and signals, you are also able to send, write messages and/or signals to user-specific networks, nodes, and IDs. This example shows an additional message called message2, which will send the signal2 as an ID 75 on the same network and node, which is used for the previous messages and signals as well. The signal2 is going to be initialized to the decimal value 127, does include 8 bits starting from bit 0, and you have also the possibility to set the little and big endian, the scale and range properties as well. Inside the service2 page, you select the signal from the message2 inside the parameter properties and assign this signal to the component. As I said before, this signal has been assigned to the same node, so it is listed in the same ECU listed called network.node, but you can assign this signal, of course, to another different network and node. So after assigning this signal to a parameter component, you can use the parameter download function to send this message or a signal to the CANbus. On this slide, I will show the XML elements, attributes, and assignments, and how these have effect or how they look like in the service tool and in the page. Let's start with the diagnostic data file. So this is included in the design folder diagnostic data with the name and the value. Then we have the network, which is assigned or available in the ECU list together with the node, which is also displayed in the diagnostic ID. Then we have the message 1, which is used in any display and parameter component on the page. Also one signal from the message 1 called angle. Another signal called Xplorer CAN ID to change the CAN ID dynamically, which is assigned as a signal to this parameter component. And the message 2, which is used to send a CAN message. Like it is mentioned in the service tool design manual, another benefit using CAN Xplorer is the CAN ID and the type of defined messages can be changed dynamically in the PLUS+1 service tool. What does that mean? So you are able to change the message ID directly in or via the service tool page. For all nodes that receives or transmits a message, the CAN ID and type for the message will be available as 2 additional writable parameters. So using DBC files, the parameters will be added automatically, but when using XML files, which is shown in this video, you will have to add these messages manually. How to implement these is shown and described in the manual as well. I will try to show this in a little example. The network, node, and message has been assigned on the top of the XML file. Inside this message, which means that this is assigned to this message and its properties like node, 2 additional signals has been added. The first signal, called Xplorer CAN ID, which is the first of 2 available parameters for the CAN ID with the length of 29 bits starting from bit 0. And the second signal, called Xplorer CAN extension, which is the second of 2 available parameters for the CAN ID with the length of 1 bit starting from bit 31. Like I showed already, how to assign signal name inside the parameter component properties inside service2 pages. The same procedure is needed for the CAN ID parameter, using the parameter download function to send the CAN ID dynamically. At the end of this video, I would like to show you the example to show you an entry point and train yourself. So first of all, you have to check the communication, that you choose the virtual connection and that the CAN Xplorer protocol has been implemented and activated. Then you have to choose the template or the example of the XML file, which does include the network called CAN Xplorer, the fixed node address 12, and two messages. The first message does include some signals like the angle with the 2 bytes, then also angle degrees, which is the same just with the factor. Then we have a byte 1 and byte 2 with some conditions as an offset, and also some AND conditions with 2 cases. Then we have the Explorer CAN ID and the extension for dynamical change, and also message 2 with ID 75, which can be sent to the CANbus. So let's start and add this diagnostic data file, choose the protocol and the XML file. So this will be included, and as you can see, you're connected to a virtual device. The CAN Xplorer node will be shown in the ECU list with the node. And let's start to create a new parameter page, give it a name, and add some parameters and some logs. So we will start with a standard parameter to add the CAN ID, to change the CAN ID dynamically. Then we will display the angle signal and the same signal with the factor, so the angle degree, and start with this 3 components. Up to now we can read out the CAN ID, which is set as default in the XML file, which is 8. And to receive data, we have to use a device or a program like a CANKing to send CAN messages. So we can skip all these windows, and we just need the main window and this controller. Choose the right channel, which is a virtual. No init access is needed for have the service tool in parallel. And under options, you can choose between decimal or hexadecimal. Numeric base, we choose the hexadecimal and open the message window. So here we can start with a CAN identifier with the 8 bytes, and start just with some data and send. So nothing happened. We can also use the PLUS+1 monitor to check if messages are on the CANbus. Yes, there are, but we have to forget to start the logging. So now we receive all these messages, change the data, and as we can see, the data will be received. Now I will show a better solution for showing the decimal point. So we use this value presentation in the component properties. You can also assign in the unit, which is much more comfortable and looks much more better. So the next thing we can use is the conditions. So we will add some components to show the byte 1 and byte 2. And also the offset and the condition. So the offset was byte 1 or byte 2 with the offset from byte 1, and the other component will be shown the condition. So this is what happened. Just shortly, the conditions, we have the byte 1 and byte 2, 8 bits, so 1 byte. But then we have the offset, so byte 2 with the offset of 1, and the condition is an AND condition with the first case byte 1 with a maximum or between the value 1 and 9, sorry, and byte 2 needs to be 7. So then we can check all these changes. As we can see, sending does not change anything. We forgot the log, so don't forget to start the logging button. So now we can check all these CANbus messages, change the inputs. Now it's 1 and 3, 1 and 4 is 5 with the offset, and the condition is still not met until byte 0 is between 1 and 9, and byte 1 with the offset from byte 1 is 7. So now we can check all these changes. As we can see, sending does not change anything. We forgot the log, so don't forget to start the logging button. So now we can check all these CANbus messages, change the inputs. Now it's 1 and 3, 1 and 4 is 5 with the offset, and the condition is still not met until byte 0 is between 1 and 9, and byte 1 with the offset from byte 1 is 7, so as it was. Until then, it was shown with a red frame. And the last one is a message to signal, just to show that it's possible to send a message or a signal on the CAN bus. So we can read out it as an init value 127. Start logging, and we can see read out 127, and this can be changed as well. And you can see it on the CAN monitor that the data will be sent on the CAN bus. Another example shows a possible use case to receive a J1939 message and read out the engine speed RPM. As CAN Xplorer does not know anything about the J1939 protocol, you need to use the actual CAN ID for a given J1939 message. For this example, MC24 guide application is used, which sends the EEC1 message using the J1939 function block library. The MC24 time is used to send a cyclic change value for the engine speed bytes, and this is how it looks like. Different constant values has been connected to the PGN 61444 data input, including the data engine speed SPN 190, which is fed from the MC24 time value and calculated with the periodic sinus function. This application has been downloaded to an MC24 controller and connected with a CG150 or any other available service tool connection. Inside Service Tool, you can set up the right gateway communication to the MC24 and check the CAN monitor if the right data from the J1939 message has been received. In this example, the PGN 61444 sends an extended CAN ID hex 0CF00 with 8 bytes. In the CAN monitor, you can see the periodic feed of the 2 bytes 4 and 5, which refers to the engine speed of the PGN 61444. Byte 4 and 5 represent the engine speed 0.125 RPM per bit. The next step will be to set up the right CAN Xplorer message inside the XML file. To do so, the correct CAN ID of the J1939 message PGN 61444 needs to be addressed as message. As you can see in this example, the message is assigned to the CAN ID hex 8CF00400, so the same CAN ID which is shown inside the CAN monitor as received J1939 message, but with the 8 in front. This number 8 is needed for extended CAN IDs to set the most significant bit of the ID. So you have to add a hex 80 million or 8 and 7 times 0 for extended CAN IDs. And after modifying the XML file, add this XML file to the diagnostic data assigned to the CAN Xplorer protocol. Inside the service tool P1D page, the engine speed is linked with the CAN Xplorer message and visualized via a gauge. We hope that you found this tutorial useful. Remember that PLUS+1 community help is available on the PLUS+1 user forum. Check out other videos on our YouTube channel or contact the PLUS+1 helpdesk. Thank you for your attention.